computer. And move my little bar over here, and we'll go over to take a look. This is, of course, the 20th of November, and I sent everybody an email letting them know I had some changes in travel plans, so I'm having to do these normally where I would be over in Shawnee. I can't be over there today. I've got some changes in travel plans. So I'm going to go through the, still go ahead and do the screencasts anyway, and you have those recorded if you can't make it yourself, and we'll go from there. This week we're going to look at a couple of cases. One of them deals with a case called AHP, or a methodology known as AHP, and that's the analytical hierarchy process. And that process is the authors of the textbook, this is the big one on management science, start over on page 677, and they discuss this process and take it all the way over to page 680, really all the way really over to 687. So and this is where we're dealing with multi-criteria decision making. Okay, now I'm going to be pretty didactic today in terms of the as I mentioned here, 677 to 687 is background reading. So if you haven't read those pages and gone through them, I'm going to spend some time doing that, okay? And I also have some resources here for you. And when we do multi-decision criteria, especially with pairing, this is a specialized technique that we can use. And you'll see as we unfold it and trying to look at preferences. We also have another case in there which is called, which deals with the scoring, okay? And that model is over in pages 672 to 676, okay? So if the background on those really would be 672 to 676. For you, probably the key part is going to be over on page 674. Here's a person, again, another multi-criteria decision making. Now, see, things have changed from when we started the course, okay, to where we were doing optimization. We wanted to minimize, maximize, or hit a target value. We've used goal seek to hit a target value, okay? But this time we're changing multiple variables, and this is kind of like, think of it like a scenario manager in the Excel, or a scenario analysis on steroids. That's probably the best way to think about this. Now, I want to show you some of the resources that I've got here for you. First of all, I have some very, very important reading for you to see over here. Herbert Simon and his theories of bounded rationality and satisficing. And what Simon said was, Simon says, I know, funny, ha, ha. Simon argued that managers make decisions on the basis, and organizations make decisions on the basis of bounded rationality. In other words, we don't know everything. And you'll recall last week as we were looking at the expected value of perfect information, trying to figure what we would pay for a sample, of data, and trying to work through that. Now we've moved this to where we openly say, okay, we understand that what we know is bounded. And this takes us back to what I've talked about in every class you've had with me, and that's what I call the Q. And that's where the quality of our decision is a function of two things. First of all, known and unknown states of nature or conditions, and then known and unknown alternatives or responses to those states of nature or conditions, okay? And so Simon says, because we operate from bounded rationality, we only know so much, and we have certain boundaries in terms of resources, etc. we engage in a process called satisficing, where we try to just find something that works or satisfies everybody. Now, this is highly, it really happens in terms of, this really goes on in terms of budgets and large bureaucratic organizations. Now, I have in here for you also a resource that discusses the difference between optimization and satisficing. And they are two different kinds of things and two different critters. Then I have another of these bedrock kind of theories that you need to take a look at, and that's what we call Pareto efficiency. And then I show you one of the model, and that's the reciprocal lattice. This is a model that's borrowed from the physical sciences, and we use this to do multi-pair or multi-wise criteria, multi-pairing criteria, or looking at multiple pairs of things. And then I have a resource there for you for weighting by pairwise comparison. Now, I would, I'd be shocked if one of you sent me an email, hey, over the holidays, and said, wow, I can't tell you what, those resources just I understand, I know. It's Thanksgiving, and probably many of you, I doubt anybody, I'm sure Shawnee looks, the campus looks like a ghost town today. It usually does. People somehow slide the holiday from starting at Wednesday back to starting at Monday. So you do have this recording here, but I would really encourage you to go over and take a look at these, okay, which will provide, well, these resources here that will provide you, okay, a way to put this into a larger perspective or build upon what's there in the text, okay? Now, I also want to show you another resource, okay? And this is, of course, this is the AHP MSX. The AHP file is due on Friday the 1st. Okay. Then here's the scoring file that's due, and I'll talk about that next week. But here's the file to use this to complete the AHP assignment. Okay. And then we'll also talk about the scoring of assignment. Now, what you want to do is you want to take the AHP file and you want to download it, okay, and download it to your desktop, okay, and you're going to see how we go step by step in doing this using the analytical hierarchy process. And so I'm going to save this as AHP5. You can see I've had it numerous times, HP5. I'll save it to my desktop, and there it is. Okay, now there are two processes that are going to go on. First is what we call synthesization, okay, and then we're going to look at consistency. Now, I want you to use this file and go through the textbook, okay? And I have it all labeled for you, and I walk you through the process or the steps of doing these pairwise comparisons, okay? I want to put the case into context first of all, okay? And this starts over on 677, okay? And this is an individual who's trying to make a decision on what vehicle to purchase. Okay, pretty simple deal. And this, our protagonist here, Diane, this is in the middle page, 676, has 4 decision criteria: price, miles per gallon, comfort, and style. Now, down at the bottom of page 14, table 14.4, we see information for the car selection problem, and we see the characteristics, okay, and those are part of those selection criteria. And then we have three cards. This is somewhat dated, of course. An Accord, a Saturn, or a Cavalier. And we see a price for each of them, a color, the miles per gallon, interior, the body type, okay, and then in a sound system. And wow, anybody's got, I love it. The tape and the CD, that's a throwback car, if anything. Okay, so but the point is don't get hung up on stuff like this. Understand that these could be any 1, 2, 3, 4, 5, 6 criteria. These could be any 6 criteria. In fact, when we look at the scoring case, we're going to see the same kind of process. Okay, so we've got these decision, the information for the selection problem. This is over on page 677. Okay, and I want you to notice something at the very, very bottom of page 677. This the footnote. Notice the date there. Okay, it's 1999. Now you would look at that and go, "Wow, this is almost that citation is almost 20 years old." Yes, it is. But this is the classic model that's been developed to do pairwise comparisons or multi-criteria decision-making. Thomas Sadie, okay, is the person who developed this, okay? And this also goes to show you that we are, in management science, still working on models, still developing them. And as I mentioned before, okay, I've got that resource there for you to go and take a look at the reciprocal lattice. That's a model that's used a lot in chemistry. So folks in management science are always looking for a model that we can use or apply in real world problems. That's what makes you a manager. That's what makes an elite manager versus a run-of-the-mill manager, to be honest with you. Now, there are those managers out there who just intuitively have such a grasp of their business and the product service bundle and the value proposition that they can just do it. The rest of us who are human beings have to learn how to do this stuff, okay? Now, so here at the bottom, and we'll walk you through the process, and then over on figure 14.6 on page 678, they give you the hierarchy. This is where we talk about the analytical hierarchy process. We put our decision criteria into a hierarchy, okay? Now, here we're trying to organize our needs or our wants or our objectives, okay? And you'll notice she wants to select the best car. Well, okay. And then she has these criteria. And then she has decision alternatives, okay? So now, don't get confused with the 6 characteristics, okay, versus the decision, versus the criteria, okay? Because some of those, the interior, I would say interior and body type is probably something, is style. Or I'd say interior and comfort are probably linked together. But what we're going to see is how the person who's making the decision makes those linkages. That's why we call this multi-pairwise comparison. You see, this sounds a little bit like correlation coefficient. The lattice, the reciprocal lattice, is like that, except we're using the inverse to create ratios and clean the data up a little bit. And you'll see that when you go over and take a look at that resource, okay? Now, here over on page 678, they talk about, the authors walk us through how you establish priorities, okay? What are my priorities, okay? And then at the very top of page 679, we see numerical ratings. Now, I want you to know something. These are not true intervals. They can't be. These are ratings. Like on a scale of 1 to 5, How much do you like pizza? Well, I'd say on 5 for sure. On a scale of 1 to 5, how much do you like turnip greens? And I'd say, well, on a scale of 5, probably a 3. Okay, but there's no meaning there because we're rating something. We're assuming ordinal level data. Okay, so as we walk there, these are almost really these numerical ratings, and then we also have to note, okay, midpoint medians that are implied there. Okay, but we've got stuff in terms of we see the 9, the 8, the 7, all of those, and then as we walk through those criteria, they're in the middle of page 679. They show us the 6. We're going to price compared to MPG, price compared to comfort, price compared to style, okay? MPG compared to comfort, MPG compared to style, and comfort compared to style. So we're doing these comparisons, okay? And then we see some more at the bottom of 679, some more of the analytical part, okay, where we're thinking through price is more moderately important than MPG, equally to moderately more. As you can see, the wording at the bottom of 679 shows you that we're dealing with ordinal data. We're dealing with ratios, okay? Well, as we walk through over on page 680, they show you can take a look at 14.6. And as the authors note there, the AHP uses numerical ratings, okay, from the pairwise comparisons to establish a priority or importance measure for each criterion. Then we come down to the empty matrix. Now here in this empty matrix, we've got 16 cells. We've got 6 comparisons, 4 diagonals, that's where a thing is compared versus itself, and 6 reciprocals. So you notice we've got these reciprocals. That helps clean up the data a little bit. And they're over on 681. We start to see the pairwise comparison matrix emerge. In fact, I have it right here for you. Here are the diagonals. Okay, and here are the comparisons. Price versus MPG. Okay, price versus comfort, price versus style. Then we have MPG versus price. Then of course the diagonal. Then MPG versus comfort, and MPG versus style. Then we have comfort versus price, of comfort versus MPG. And then we of course have the diagonal, and then comfort versus style. And we see that whole process. The diagonal, of course, are the ones. So we have the first pairwise comparison matrix, okay? And that's that's at the bottom of page 681. Okay? Now, the next step that we take is we begin a synthesis. Now, they're at the bottom of page 681, excuse me. They explain the reciprocal process and how that's and how that is obtained, and they talk about that. We complete. See, once we've done that, if you look in the middle of page 681, we have the diagonals. Then we do the comparisons. And then we do the reciprocals, and that's what fills in the whole matrix. Okay? And so we end up with those. Now, I went ahead and put those, rather than using fractions, okay, I just went ahead and expressed them as decimals. That's all. Now, over on page 682, they give us the first step in synthesization, okay? And as the authors mentioned, it's way beyond this text, the underlying mathematics of it, okay? But what we're doing is we're normalizing these data, and the authors allude to that at the top of page 682, where they talk about we have a normalized pairwise comparison matrix. So we've normalized them, and how we've normalized them is we've used the reciprocals, okay? And now we're going to do that synthesis. And they walk us through this where the synthesis, the first step is we sum the values in each column. So now we've created summary data, okay? Then we divide each element in the matrix by its column total. Now notice we have a sum, and then we begin to work, then we begin to put that sum, then we begin to put each value in comparison. And you notice this is, okay? Here we go. All right, here's this. So we're almost creating ratios. Up here we flipped them. We use the reciprocals. Now we're using ratios or percentage data, if you will. I would say, well, a percentage, because we don't have a true ratio. So we divide each column, each element of the matrix by its column total. Now, this is a precise process, okay? And to do it right, you can't skip steps. And I would say, very frankly, even there's software out there that's designed that will do this, okay? Marketing people use these. Use some of the proprietary software that's out there. People that work with transportation problems, people that work with product development issues, you know, working through that, trying to analyze what's the hierarchy in terms of what we want, and then how do we express that and model that to get to where we want to be. Now, the second step, so we've divided each element of the matrix by its column, okay? And then the third step is we average the elements in each row, okay? So then we just get we get the average of, average the elements in each row to determine the priority of our criterion. And that's the third step. And they show us the results of that process at the very bottom of page 682. Now, you see what we've done to build the matrix, okay? Then we've used the reciprocals. We built the matrix with the comparisons. Then we used the diagonals. Then we used the reciprocals, okay? Then we created summary data, the sums for each column. And then we did the synthesis where we divided each element of the matrix by its column total. And then we averaged the elements in each row to determine the priority of each criterion. And that's just, here's the priority, and you'll see. So notice that we did summary data, then we did the synthesis using the summary data, and then we produced a second piece of summary data, an average, or an average is a measure of central tendency. Now, I talked about this last week, and you've heard about this in statistics. All statistics boil down to the following: the extent to which observations cluster together. Okay? What's typical, i.e. the average? To what extent are they not clustered? Is there dispersion? And that's going to be, and standard deviation is going to tell you some of both. And we did a case where we did outliers. Okay? And so we're always looking to put a value into some kind of perspective. And we do that here using the average. So we've really been in a process of cleaning these data up, okay? Now, the truth is this case, as far as I'm concerned, uses big data, all right? But the only thing here is we have data from one consumer. But if I had 10,000 of these, then or 1,000, I'm talking about big data. But the truth is, when we talk about big data, it's not so much how much of the data we have, it's how we handle it, okay? That's really the secret to this, and that is, notice if you recall when we did the foreman text, we took those tweets and we stripped them down so that we could count them, okay? Remember that we standardized scores. We're doing pretty much the same process here, okay? And so we come to the point. Hi there, and see who we got here today. Hi, Alexander. Glad to have you here. I started pretty early, so you'll want to double back and see some of the stuff we talked that I covered. So we'll get on from here. Okay. All right. Now let me do this for a second. Pop this up. Did you have any questions I can answer for you? Let me unmute you. Any questions? Okay. All right. Well, I'm gonna go ahead and go on through here. So, as I was saying, and Alexander, you'll want to look at the minute mark and find this, and then we'll really go back and follow through. I'm sorry. Did you have? Let me see. Let me put these earphones on. See.
I'll watch the part I missed when we get through.
Oh, well, yeah, you want to go back to the very start. When I record the video, when I process this and then post it, you'll want to go back to the very beginning.
Okay, I'll do that.
Yeah, there's about 25 or 30 minutes that I did, so I could make sure I could get some time constraints I'm under handled. Okay. Yeah.
I'll go back and do that.
Yeah, that's fine. And then of course you can always you can continue on, but you'll probably want to start at the you will want to start at the beginning and then come forward, and that's okay.
I'll do that. Thank you, sir.
Okay. Now I'm going to go ahead and let's see. Let's continue on here. Now, again, we've done the synthesis. Okay, for this pairwise comparison, we're working with the AHP problem over in chapter 14, multi-criteria decisions. So there at the very bottom of page 682, we've got the average, so we're able to determine the priority of each of these elements. Okay, so we've got that synthesis, and that's really the third step in that process. Now, over on page 684, okay, they show you how to get the weighted sum vector for each of these, okay, and they walk you through that to get a randomly generated pairwise set of comparisons, okay, and then use that to get a consistency model. Now, I'm going to click on this tab. Let me go back for a moment. Here we've come down to we have the priorities, and we've processed these data. As I said before, big data is more about how you handle unstructured data like ratings than just the volume itself. So here we've come down, we have a priority where we have the average, okay, of these comparisons. And again, remember, we had the diagonal, and this is based on the model of a reciprocal lattice. And then we had comparisons of price versus MPG, etc. So we're doing multiple pairwise comparisons. And now we're ready to say, okay, here's what we have Is it consistent? Now, this is very similar to the process that we did when we had the case of the Foreman text, okay? And we had the case of the Foreman text, and in that situation, what we did was we stripped all those tweets down, and then we created we took 150 we took 20 tweets that we knew were about the product and 20 that were not, and we used and built a predictive model. Well, the consistency ratio, and the authors walk you through how all that's done, getting a weighted sum vector and computing a consistency index, okay, and then getting that comparison matrix and that consistency rating, okay, and we're going to run that. Now, this is not too much different than if I were working with simple count data, or I was working with just very simple data I would put into a chi-square coefficient, chi-square. I'm going to run the chi-square and look at the coefficient to see how rare. First of all, to see how rare it is. Okay, is there one column or attribute, or is there one cell in the two attributes? Okay, that has far more observations or far more counts than we would expect. Okay, so but in this case we're looking for consistency. Okay, and I walk you through it. I give you here over the first step over on page 683, and I walk you through that process, and then the second step, and then the third step. And all I can really say is that to do this and do it correctly, okay, you have to follow this process. Now, the problem becomes when we have multiple decision makers and multiple decision criteria. That's where this gets really hairy. And what you almost have to do, and there's some proprietary software out there that will do this, is walk through this process for every single decision maker. Okay? Now, sometimes let's say this involves somebody selecting a car, and sometimes the decision makers, if there are multiple decision makers, will satisfy. So that's why I said one of those resources over there I want you to look at is Simon's statement, is Simon's ideas about satisficing, where everybody agrees to say, okay, well, all right, let's give it this score, okay, and this will happen and this is one of the ways that we do this is what we call a kind of a Delphi process, where we have a bunch of people we think are experts. We have the key decision makers, maybe the executive team, and they all come together and they come up with ratings, and then we run it through the model. Okay, I don't know that you're going to get that much better set of results if you have an amalgamated one than you would if you took everybody's individual results. My hunch is you'll get some very, very odd looking consistency ratings, and then you'll have to make some decisions. Anyway, so you can really, if you have 5 decision makers working on the same criteria, you can run through the 5 and then come up and say, okay, which one of these is the most consistent? Okay. And I give you some of the mathematics and show you how some of that's done. Here's a vector, okay? And we get the weighted sums, and then we compute vectors. And again, this process, like most processes, almost every process in management science, is borrowed from some kind of model, and in this case, it's borrowed from the model of the reciprocal lattice. And to see that, you'll have to go back and see how this is called the analytical hierarchy process, because the decision maker comes up with criteria and then puts those criteria into a hierarchy. They prioritize their decision criteria, and then they start to do pairwise comparisons. And so that's, and again, that's why if you go over to page at the bottom, page 679, price is moderately more important than MPG. Price is equal to moderately more important than comfort. Price is equally to moderately more important than style. As you can see, we're looking at ordinal data, and we're doing comparisons greater than or lesser than or moderately more important or much more important, and trying to parse through those nuances and then put some numbers to them. Okay, but this is it's not the process is, this process is simple, okay, but it's rigorous. I don't know how else to say it. Rigorous meaning you got to follow the process. Okay, people who try to fudge on it will find you just won't get the kinds of results that you want. But and this is really a baby case, because we're taking one person with a fairly limited set of criteria, okay, and running and using the model. Okay, so this is what you'll want to upload for the AHP case when we cover it. All right, I'm not going to say too much more about that. I'm not going to save anything there. I'm going to go back over here to the modules, okay? And like I said, I started pretty early today, so I can get some time constraints handled. Now, we're down here, and so, and again, I want to emphasize to everybody, to really get the most out of this case, okay, to really be able to sink your teeth in it and to understand on a deeper level what I call the philosophy of management science, okay, or for a better want of a term, a methodology. Now, let me stop for a minute and say, when you hear people use the word methodology, they're talking about an approach, how I approach a certain method or set of methods. Methods are how I do things, but a methodology is more of a philosophical approach. I'm going to give you a really simple example out of football. Okay, let's take let's take what would be a good team to take a look in college football. Probably you'll hear about people who run the West Coast offense or an air raid offense, which they throw the ball a lot. Okay, now that's a methodology which says we're going to throw the football to stretch the field, to make the defense have to cover a maximum amount of territory, to wear them down physically, to wear them down mentally, and then hope they make a mistake and we get a big play. That's a methodology. Methods would be I throw a ball almost a lateral to a back who bits 3 yards off of a pass play, and then I occasionally throw the ball down the field vertically really far to see if I can get an interference penalty or something. So it's methodologies and methods. So if you really want to understand the methodology, this will tell you about. And this also, it's important, I think, to understand Simon, who talks about theories of bounded rationality and satisficing, where he says our knowledge is limited and our tendency is to work within the boundaries of our knowledge. And there's also a tendency for us to satisfy, that is, to get the answer or to apply the method that is politically or emotionally satisfactory to everybody. Not necessarily from a rational standpoint the best thing to do. And then, yeah, then I have some material there on satisficing versus optimizing. And then I have a resource there in terms of what we call Pareto efficiency, and then the reciprocal lattice, and then some information weighting by pairwise comparison. So some good stuff there for everybody to take a look at. And we've just been using the AHP file, and this is the one to upload. Now, the other case in here is the scoring problem, okay? And that starts over on page 672, okay? And it walks this, and we go all the way from 672 over to 676. And the authors talk about scoring models and a quick and dirty way for us to look at our decision alternatives. And what they have here, they walk us through the steps at the bottom of page 672, okay? And then we come up with a score for each decision alternative, and they walk us through how to do that. And they're in the middle of page 673. This is a person who's going to go out and find a job, okay? Or they're looking, or they maybe have some multiple offers on a job, and they have a set of criteria, okay? Career advancement, location. Then they weight those on a scale of 5 to 1. Again, we have ordinal data ratings, and these kinds of things are the staples of people who look at multiple criteria, decision making, decision models, or are wanting to find out how. Well, we just saw an example with a person making a decision about buying a car. Now we've got a person who's making a decision about a job. Which one am I going to take? And notice there at the bottom of page 673, we have a set of weighted scores. Anytime you see a set of weighted scores, like a set of weighted job selection criteria or a set of weighted, a weighted portfolio, okay, you're looking at that same kind of approach. All right, and they have some. They also add levels of satisfaction, and then at the bottom of page 674, we see the raw ratings. Okay, for the decision criteria and alternative combinations in terms of a financial analyst, an accountant, or an auditor. Which one am I going to be? And in the middle of that, they show us how to get that decision alternative and how to do the scoring for that. And it's all weighted stuff. And then you can see that over there in table 14.3. Okay? And again, it's using a weighted process. And kind of, it's, I guess you say, well, why wouldn't they just use the AHP? Well, he could, but this is just more, the scoring model is more of a kind of a quick and dirty. Now, both of these assignments are due December 1st. Okay, make sure you remember that. I don't have anything due from you for. They're not going to ask you to turn something in on Thanksgiving Day or the day after. That's crazy. But here we are, and I'm going to ask you to use goal seek to obtain a value of 167. So that would be what I'm going to ask you to get done. Okay. Now, I'm going to go back over here for a moment and just logistically keep us kind of on track. Okay. And we'll come down here. And we're in module, this is module 13. Okay. And we have these two assignments that are due on December 1st. And that's AHP, and then the scoring. And then we start into next week, which would be a week from today. We go into just, there are no classes. This is just a pure flex time kind of week. If you've had a course with me before, you know that I do this as we come to the end of the semester, especially when I have some large projects for you to do, and they give you an opportunity to do those and to get to work on the final exams. So Again, I'll be covering some of this territory next week when I just come on and talk about. But here are the instructions. This is the SAP, okay? And you want to go over there and the Part A instructions, and then where to upload it, SAP, Part B. And let's look at that for just a minute. Okay, and there's a YouTube video. I want you to search over using SAP Business One. Okay, and I want you to do this so you can have some familiarity with that tool. SAP is one of these tools that we use, like SAS Visual Analytics, SAP. There's Oracle, and part of this is just to let you see what that is. Then there's also, you have the Anderson Text self-developed quiz, okay, and that'll be due. When is it due? December 8th, which is 2 weeks. Yeah, next Friday would be the first. So it'd be a week, 2 weeks from a week. Just 2 weeks from this coming Friday, excuse me. And then the final exams, and that's where we sit. Well, I've covered a lot of ground today, and as I said, I started about 15-20 minutes early, so I'm going to end the stop the share and stop the recording. And I hope everybody, if you probably will see this next week, is my hunch. Maybe some of you will look at it today, I don't know. But again, if you're traveling somewhere, be careful, be mindful of the fact that when you start to head north and northeast, you're going to run into some really, really nasty weather. And that's kind of one of the constraints I'm having to deal with right now. So I'm going to stop the share and stop the recording. And folks, have a happy Thanksgiving.